Hello, today we're going to look at the definition of the derivative, and we're going to use the definition of the derivative to find the derivative of functions. Now, let's, oh dear. Okay, let's write the definition of the derivative for a function over here to the side. So if we have a function f at x, the derivative equals a limit, we can do it as h approaches 0 of f at x plus h minus f at x over h. So I think in most cases we're going to use this definition. There's another definition if we're looking for the derivative at a particular point, say a, then we have the limit as x approaches a of f at x minus f at a over x minus a. So we may use either one of those depending on the situation. Okay, so now let's go to our first question. Use the definition of the derivative to find the derivative of the following functions. All right, need a bit more space. Okay. Okay, so our function is f at x equals the square root of x minus 4. Interesting. Okay, so let's just write out the definition. It was a good place to start. That's an h, a funny looking h. Limit as h approaches 0 of f at x minus f. That's not right. I'm thinking of the other one. F at x plus h minus f at x over h. Okay, so let's start plugging things in. So limit as h approaches 0. So f at x plus h. So our function f at x is the square root of x minus 4. So the square root of x plus h minus 4 minus x minus 4 all over h. All right. So now what do we need to do? We need to somehow remove these square root signs. So this is where rationalizing comes in. So let's just write out what we have. Okay. Okay, so now we need to multiply this by conveniently chosen number 1. All right. So we're going to multiply it by the square root of x plus h minus 4 plus the square root of x minus 4. Okay. Okay, so doing this, let's see what we get. Let's hope we have enough space. All right, so again, we have the limit as h approaches 0. Now in the numerator, what do we get? We get, sorry, let's do it this way. The square root of x plus h minus 4 times square root of x plus h minus 4 gives us x plus h minus 4. If you notice, this product in the numerator is actually a difference of squares. So the cross term disappears, and we're left with x plus h minus 4 minus the square root of x minus 4 times the square root of x minus 4, which is this x minus 4. Okay, so actually we have x plus h minus 4 minus x minus 4 all over h times square root of x plus h minus 4 plus square root of x plus 4. Okay, so now let's simplify the numerator. Limit as h approaches 0 of, all right, so here x's cancel out, our 4's cancel out, and we're left with just h in the numerator. We have an h in the denominator times the square root of x plus h minus 4 plus square root of x plus 4. Okay, let's continue over here. The h's cancel out, so we have 1s, and we have the limit as h approaches 0 over, we'll write that in, 1 over, good. The numerator, we're left with the square root of x plus h minus 4 over plus, sorry, the square root of x plus 4. And let's just move over to the right a little bit. This equals, now we can just plug in 0 for h, and we end up with 1 over the square root of x minus 4 plus the square root of x minus 4, which equals 1 over 2 times the square root of x minus 4. So that's our derivative. And we use the definition of the derivative to find this. It takes a bit of time, but it's worth doing a few times just to get the experience. All right, second question. Our function is f at x equals 2 over x, and we're looking for the derivative at x equals -3. So we're looking for f prime at -3. So in this case, why don't we try the second definition of the derivative? So limit as x approaches -3 of f at x minus f at -3 over x minus -3. Okay. Limit x approaches -3 of 2 over x, minus 2 over -3 over x plus 3. Okay, so let's start simplifying things a little bit. Limit as x approaches -3 in the numerator. Let's see what we can do here. I'm trying to think. Let's put everything over a common denominator. 2 times -3 minus 2 times x over -3x all over x plus 3. All right, let's see if we have any space below. We have a little bit. Okay. Limit x approaches -3. Okay, so in the numerator, we can factor out a -2. And then we're left with 3 plus x over -3x over x plus 3. All right, so 3 plus x is the same as x plus 3. We can, maybe it's a bit easier to write it this way. We can factor out the x plus 3 factor in the numerator and denominator, and we're left with the limit as x approaches -3 of -2 over -3 times x, and this equals -2 over -3 times, as x approaches -3, we end up with -2 over 9. Good. So we've used the definition of the derivative to find the derivative of a function, both at a general point x and at a specific point. In this case, x equals -3. All right, so that brings us to the end of our session today. If you have any questions, give us a shout at info@raisemymarks.com or give us a call, day or evening, and we'll be happy to help you. Thank you.